Describe how a person perceives visual stimulation by indicating the parts of the eye that we discussed yesterday in class. So we talked about the eye, talked about parts and functions, and obviously about photoreceptors. I mentioned that towards the end. There you go. You finished? How's your knee feeling?
It's fine because I started using it.
Oh, okay. All right, yeah, go ahead. All right, so let's get to it here. So describe how a person perceives visual stimulation by indicating the parts of the eye discussed yesterday in class. So let's start with the layers of the eye. So what is the outer layer where the muscles attached for eye movement and really the form of the eye? What's that called? What's that outer layer? What's that outer layer? It's white. Hadley? Sclera. Good job. Good job. So again, form of the eye, muscles attached to it, allows for eye movement. Good. Good. All right. What about the middle layer of the eye? Contains blood vessels. Middle layer of the eye. Anybody. Allison, you have that? Cool, Roy. Yep. Good job. Good job. And we talked a little bit about it yesterday under extreme fatigue or intensity, maybe blood vessels might appear actually through the sclera, or just with lack of oxygen, okay, that might occur. Or if you just get poked in the eye, right? If you might have any type of debris in your eye, you could see the choroid, actually, blood vessels appear through the sclera. Good. What about the inner layer of the eye? The inner layer of the eye. This is where the photoreceptors are located. Christian, you know? No? Okay. Watch the video lesson. All right. Hadley, you have it? The retina. Yep, good job. The retina. Good. So make sure you guys remember those layers of the eye we talked about yesterday. Good. All right. What about the pretty much like a bubble almost, right? Is where the light actually enters through the sclera. Where does the light enter through the sclera? What is that called? That part. Inside of it, we know is the iris of pupil. What is the outer layer? It kind of bubbles out. And this is where light enters through the eye. Caitlin, do you know? Okay. Okay. Anybody want to help? Brayden, go ahead.
Is it the eye?
No, those are the photoreceptors that are located in the fovea, part of the retina. So this is where light enters right through the eye. The first part starts with a C. Cornea. There you go, the cornea. Okay, so as light's entering through the cornea, it is then refracted, it's bent depending on the brightness of that light. And this is where your eye color is located. What is that called? This is a muscle fiber, it's flat. And again, eye color bends the light rays depending on how bright it is. Raven? No? The song by the Goo Goo Dolls. Allison? Iris, yes, there you go. There you go. The iris, good. And then light enters through the iris. So inside of the iris is what? It's a black formation, it's black. Go ahead, Hadley. The pupil, good job. And right behind the pupil, this is actually bending the light rays to the back of the retina. And what is that called? It's bending the light rays. Go ahead, Ray. The lens, yes, good job. Good job. So see where we're getting at here, okay? All right, so as it's bending the light rays, the lens is projecting this light to the back of the eye. So this is the internal layer, the retina, right? And this is the location of the retina where there's mostly located the photoreceptors. There's a dense location of photoreceptors at this location. What is that called? So this is the inner layer of the eye, the retina. Okay, this is where the dense location of photoreceptors are located. It's very close to where the optic nerve is at. Raven? The fovea. Yep, good job. So then the photoreceptors are they are receiving this neural stimulation through synapses, the ganglion cells, the bipolar cells. And what photoreceptor is receptive to color? What is that? Starts with a C. Cones. Yep, good job. And then dim light. Allison? Rods. Yep, good job. So then it's sending this information through neural messaging, ganglion cells, bipolar cells to what? And this is a direct path to the part of the brain that understands visual stimulation. Go ahead. The optic nerve. Yep, good job. And are there any photoreceptors located of the optic nerve? No. Good job. Good job. And we'll talk about that today with the blind spot. Good. So then the optic nerve relays this neural information to what part of the brain? To be perceived, to understand what you're visualizing. Go ahead, Allison. The visual cortex located where? The occipital lobe. You guys got it? I know there's a lot going on there. Okay, especially with the anatomy of the eye. So make sure you guys know that. Remember that. It's important. So I like you guys to work on this assignment here in class. We'll go over it here soon, but I would like you to work on it now. Shouldn't take you too long to complete. So this is making sense of everything we just kind of talked about here. So the anatomy of the eye. Here's what it looks like. Okay, there you go. There you go. So you're just going to fill in the locations here of the terms we just went over. Okay. And as you can see, there's two B's. That just means it's kind of bending around one part. I won't give it away just yet of the eye. So just complete that assignment. We'll go over it. I'll give you, I don't know, how about 5-10 minutes? Does that work? All right, 5 to 10 minutes. I'll let you guys complete this. We'll go over it. Just make sure you submit it on Canvas though, so I can give you a grade for it. If you want to, you can write it down on Google Doc, your notes, and then you can just attach a picture to it. That might work better for you. There you go. Is everything all right, Christian? What's that? Uh-oh. What's that? You can if you want. You can write it down. Like I have it up here. You can just put A, B, C, D. You know what I mean? Take a picture and attach it. Or can't you? Oh, let me edit it. Should be able to. No, you can take a picture and submit it that way. Okay, I made a text entry box then. You can file upload. That should work then. Jeez, needy. Holy cow. What?
My pencil fell in my car.
Mm. What is this snooty peacock, Kiara?
Huh?
What's snooty peacock?
I don't know what it is.
Yeah, I see that, but I just didn't know what business it is.
I don't know.
And the Dodge. Give me another minute to finish up, and we'll talk about it. Hey Haley, for your subliminal message assignment, can you make it shareable to me? I can't access it. All right, so what do we got here? A, what do we have for A? Caitlin, what do you got for A? The optic nerve, good job. And what does that do? What does that do? You don't know? Anyone help her? Optic nerve, what does it do? Main function. Allison, go ahead. Thank you. All right, good job. So this is transmitting this neural information to the occipital lobe. You got it, Caitlin? Good. Good. B, what do we have for B? Christian, what do you got? Yeah, the iris. Good job. So we know that the iris is here, B. And what's its main function, Christian? Color of your eye, and what else? Yeah, good job. So depending on how bright that light is, it is going to retract that light to be reflected to the back of the retina. Good job. Good job. We talked yesterday a little bit about these photoreceptors, and when you first wake up in the morning, obviously your rods are more associated at that time. They're more active. So again, the dim light, you're adjusted to. So when you see this bright light, these bright colors, again, you're going to squint. You're going to kind of turn your head because it's just too much stimulation all at once. Does that make sense? All right. C, what do we have? Brady, what do you got for C? The cornea, good job. And what does that do? Main function. Protects the eye, good job. And that is where that light is first entering through the eye. Good. D, what do we have here? Madison, what do you have for D? The pupil, good job. So the iris is bending that light through the pupil. Okay, and right behind the pupil is what, Kiara? The lens, good. And what is the main function of the lens? Okay, so light is entering through the pupil, right? And it's being bent by the iris. And what is the lens going to do? It's going to project it, right? Yeah, it's going to project the light to where? And that is what? E, we already have the lens. F, where is it going to project it to? What is F? No, what do you got for F? The fovea, yeah, good job. And that's where that is a part of the retina where most of the photoreceptors are located. Good job. And G, inner layer of the eye. What is the inner layer of the eye, Hadley? The retina. Good job. All right, is there any questions? I think that's an easier way of understanding the parts and functions of the eye. And make sure you guys use that as a study tool because you'll probably see that on a quiz sometime soon. All right. There we go. There we go. Well, the test definitely. I don't know if we'll have a quiz anytime soon. But the test. All right, terms for today. I don't know how far we'll get, but we'll talk about the light spectrum more tomorrow, I'm guessing, just the way things are going. So the blind spot, visual cortex, and opponent processing theory. Here we go. Again, guys, make sure you turn in that assignment of the eye that I just had, classwork assignment, so I can give you a grade for it. Should be pretty simple. I'm just labeling it. All right, so the blind spot, what do we have? What do we got for the blind spot? Andrew, what do you have?
Small portion of the visual field of the eye that corresponds to the position of the optic disc.
Okay, good. So where the optic nerve is located, we all know that there's no photoreceptors there. Okay, there's no rods and cones. So if light is bent onto the optic nerve, if it is associated on the optic nerve, there's no way we could perceive what we're visualizing, right? There's no way we can perceive that because there's no photoreceptors. Does that make sense? So as the light is being projected on the optic nerve, there's no photoreceptors located there. So we can't perceive that, let's say, visual stimulation. And there's a little test today I like to show you with the blind spot, and most people it works. Some people say it doesn't work for them, but we'll try it out. Visual cortex, what do we got? What do we have here? No, what do you have for the visual cortex? What's up? Oh, okay.
The primary visual brain that receives
All right, good job. So with color, motion, form, and depth, right? So the visual cortex is processing all of this all at the same time. And I'm sure there's many examples you can come up with maybe driving. I know when I drive with my friend sometimes, and he has no depth perception whatsoever. We're driving up to a stop sign, and he's like slamming on the brakes as we're getting closer and closer. I'm grabbing the handle, I'm like, oh, we're gonna go out on the road, look out. And he's like, oh, we're fine. I do this all the time. Wow, okay, pardon your brakes, buddy. But anyway, the visual cortex is all being processed all at the same time in the occipital lobe. Okay, and there's a lot going on, literally within milliseconds. Okay, opponent processing theory. What do we have? Raven, what do you have for the opponent processing theory?
It's the psychological and neurological problem that accounts for the wide range of behaviors in color vision.
All right, good job, good job. So we only can perceive really forms of color. We'll talk about this more with the light spectrum. As light is being bounced off of objects, as it's being bounced off of different things that we're visualizing, okay, our brain actually is associating that with color. Okay, it's not actually like these objects have color. It's just the way the light bounces off of these objects and we perceive it in our brain. And we all know that everybody perceives things differently. So if you're colorblind, obviously you might pick up on these different types of colors differently. So again, these objects actually don't have color at all. It is just the way this light is bouncing off of these objects with different frequencies, wavelengths, okay, which we'll mention more tomorrow, and their amplitude, that we pick up and perceive this information, okay, which I think is pretty interesting to think about. All right, so we'll talk about that a little bit. Ooh, kind of running low on time. Let me get to the visual cortex and see how far we get. Maybe we'll just talk about color blindness tomorrow and the light spectrum. All right, so we finished up talking about rods and cones. So rods, we know, associated with dim light. Okay, I know I gave the example already. When you wake up in the morning, your rods are more active at that point because your eyes are closed. Okay, and it's not really picking up on color. It's not picking up on light that is being perceived in your brain. So when you wake up, you might be a little bit sensitive to light coming in your room because, again, these cones aren't active at the time. Does that make sense? That's why you might squint. You might turn your head when you first wake up and the light's entering your room. And again, it's just because your rods are more active at that point. And a good example is if you're in a movie theater or in your dark room, you get up, you can actually see the formation of certain objects in your room to kind of walk around, right? And it's almost like you have night vision in a way, like you can actually see some of these formations of objects in your room so you can walk without tripping. And same thing in the movie theater. Okay, as you get up, you can kind of see locations of certain objects or maybe people so you can walk around them. But when you first walk in that movie theater, it's pretty hard to see, right? Because your eyes are, again, associated with cones, with color. And when you first walk into that room, again, the rods aren't active. All right, they're not activated. So it's a little hard to see. But again, with sensory adaptation, eventually you can actually see through that dark room because your rods are more active. I was actually walking in a movie theater about 2 weeks ago. I was going to see, I think it was Halloween with my buddy, and we're running a little late. So as I was walking in, the theater was dark. I tripped over the seats and fell over on the floor. It was funny. I was like, "Oh, look out! Mike Myers got it." So, yeah, funny. Anyway, the fovea, we talked about that. That is the part of the retina where most of these photoreceptors are located. Okay, it's very close to the optic nerve. Okay, as the light is being bounced onto the fovea, that is where this information is being processed, right? That's where this neural information, I won't say process, but that's where this neural information, the stimulation is being sent to the optic nerve to be processed in the occipital lobe. All right, so the blind spot, okay? The blind spot, again, is that part of the optic nerve. If light shines on the optic nerve, there's no photoreceptors there. So we can't perceive what is being stimulated at that time. We can't perceive what's in our sight. It's very much like when you're driving. You're looking at your mirror, okay? You might have a blind spot, right? You might have a part where you actually can't visualize, you can't see it. And objects might appear a little bit closer than what they really are or further away, okay? It's very, very similar. So there's an example here. When you stare at the dot for a long period of time, eventually you won't be able to see the car. And I'll just go to the book right now so you guys can work on it. So or you guys can look at it and check it out on your own. Actually, I think that's what we'll finish up on since we're running low on time. But in your book, there's a good example of this. So page, what is it? 216. So your blind spot. You can obviously look in your book, or you can go on the online textbook. I have that on the module. I think it's pretty cool to see and check out. But the point where the optic nerve exits the eye is a blind spot. When light hits the point, the eye registers nothing because the area lacks photoreceptors, neurons that are sensitive to light. Find your blind spot by holding the diagram below about 3 to 4 inches away from your eyes. Okay, so you have to hold it pretty close. Make sure the cross is on the right. Close your right eye, then look directly at the cross with your left eye. Notice that you can see the dot. Focus on the cross, but be aware of the dot as you slowly bring the diagram toward your face. The dot will disappear eventually. You try it out. It is 216. 216. So as you're bringing it closer to your face, it should disappear. It should disappear. And that is the blind spot. It's a good example of it. Didn't work for you. It should. It should. Allison, is it working for you? No? It actually should work. It should work. It's weird, but it should work. You really are bringing it up. What's that? So another dot appears for you? So that is the component process in theory then. So another dot appears for you when actually there isn't one there. Is it not working for anybody? It should. It should.
Usually,
What's that? The car.
usually the background.
Yeah. All right. Well, anyway, that's what we'll finish up today since we're running low on time. Check it out on your own, I guess, maybe with your iPad at home. It does work. I promise it does work. It is interesting to say the least. And we'll talk about color blindness tomorrow and electromagnetic spectrum.